Okay, what do you guys think about the first blank?
Function.
See, I told you you knew this. So a function is a mathematical relation that maps a set of input values to a set of output values such that each input is mapped with exactly one output. It's definitely the only word that will fit in that one. Alright, and then there's just some notes that in probably Algebra 1 when you learn this, you would use a vertical line test to determine if something's a function. Towards the end of the year, we're going to talk about polar functions, and that won't work. Polar functions won't pass the vertical line test. So instead of using the vertical line test or using those words, we're just going to make sure we say stuff like each input has exactly one output. Okay, so input is what goes into the function, obviously. A collection of the input, you guys remember what that's called? Domain or range? Domain, good. And is the input the independent or dependent variable? It's independent. So you can put anything you want to into a function. Well, not always. But the output depends on what you put into. So do you guys know what the output values are called? Range. And it is represented by the dependent variable. Okay. All right, so we're gonna do some things like these two things you've already done. Finding where a function or a graph is positive or negative and where a function or graph is increasing or decreasing. We're going to learn new things about being concave up and concave down, and then deciding those two things about the rate of change. So all that's new. It's actually a lot of new stuff for the first day, but you're going to be fine. But this first part, you already know that a function is positive when it's graphed above the x-axis, and a function is negative when it's graphed below the x-axis. Or you can think that the y values are going to be positive when the function is positive, and the y values are going to be negative when the function is negative. So that's important. I think you already knew that from before. In this class and in AP Calculus, we focus on multiple representations of functions. And so we talk about the graphs and the analytical representation, which is the equations, and the numerical and the verbal. They're all important, equally important. Okay, so we're going to start with kind of a challenging example. So we have this vase, it's an empty vase, and at time t equals 0, water begins pouring into the vase at a constant rate until it is full. Which of the following depicts this situation where time in seconds is the independent variable and the height of the water in the vase in inches is the dependent variable? So water is getting poured in at a constant rate. For this vase, is the height changing at a constant rate? What do you think?
No.
It is not. So if it was like my coffee mug or her water cup right there, then it would definitely change at a constant rate because there is no width change. But if you think about it, like it's going to take more water to fill here than it would to fill here. So the height should not be changing at a constant rate. So which one of those choices can we just mark out?
A.
Yes. That is showing a constant change in the height. Okay, let me ask you another question. So we're pouring water into this. Is that height ever going to decrease?
Yeah.
The height is going to decrease if you're pouring water in? Okay, so which one can we mark out?
C.
C, because we have a section where the height's decreasing right there. That doesn't make sense for this vase, for any vase, unless you start pouring out and pour it in. Okay, so what we're going to do is right here is the dividing line. And so above that line, the diameter is decreasing. And below that line, the diameter is increasing. Right, in both of these cases, no matter what, because there's no leak in the space, the height is increasing. Alright, so it's going to obviously fill up from the bottom, so let's focus on the bottom first. Alright, and so we're filling in the water. Do you think that the height is increasing slower or faster compared to the bottom in this section? I said that really weird. Okay, so we'll compare right here and right here.
It starts out faster.
Right, so it's increased, the height is increasing, but as we go up, it's still increasing, but it's slowing down because it's getting water. It's taking more water to change the height. So at that bottom, the height is increasing at a decreasing rate. Okay, then we get to that section where it starts getting narrower. So where the height is still increasing, but it's increasing faster because it takes less water to start moving up. So the height is increasing at an increasing rate. Okay, so keeping that in mind, let's look at our choices that are possible, B or D. So we want to find one where at the beginning it starts slowing down, how much it's growing, and then it starts speeding up. What do you guys think? D. Alright, so it's kind of growing fast, and then it slows down, and then it starts growing fast again. So this section right here is what increasing at a decreasing rate looks like. And then this section right here is what increasing at an increasing rate looks like. And that's a lot of words. I don't want to freak y'all out with all these words because we're going to talk about it all year. So this stuff we're learning today, we'll revisit all over and over and over again. Okay. There's a lot of information in this table too. So I think you guys know that when a function is increasing from left to right, we're going upward. And then a function is decreasing from left to right, you're going downward. What I don't think you know are these two terms. So a function is concave up. I say concave up looks like a cup. So you can kind of picture a cup. And concave down looks like a frown. And you can have a part of a cup. So sometimes you just have this much concave up, and that's fine. So half a cup is still concave up, and half a frown is still concave down. But that's down, and that's up. And then this is the main focus of the new focus of today. When a function is concave up, the rate of change is increasing. It doesn't matter if the function is decreasing, the rate of change is increasing. So let me show you a couple examples, because sometimes people don't believe me when I say that. So first, rate of change. When you think back to Algebra 1, what did rate of change kind of correlate to? It was like a super big concept in Algebra 1. What do you remember learning about in Algebra 1?
Slope.
Slope. Okay, rate of change is slope. So every time you hear rate of change, just think slope. And so we think about like what the slope is in this little section right there. I'd say that slope is about -2, right? And then here we'll say is about -1. And then that's -1/2. And then that's 0. And then that's 1/2 again. And then it's 1. And then it's 2. What do you notice about the values here? Are they increasing or decreasing? Increasing. So those are our little slope values. The slope is getting bigger because it is concave up. And then we can look at the same thing here. So here's a little slope. What would you guys guess that slope is?
2.
Sure. And then 1. And then 1/2. And then 0. And then -1/2. So again, what do you notice about these values? They're getting smaller, they're decreasing. Concave down, the rate of change decreases. Okay, so I'm kind of skipping over a bunch of his words, but I think we're good. Alright, so here we go. This graph has no concavity, it's all straight lines. So this one is this is definitely one where you could have done last year in Algebra 2. So the question is, so we have a piecewise function. What are the intervals at which the f is increasing? All right, so I'm just going to highlight sections of increasing. So anytime as you go from left to right, we're moving up. The function is increasing there. So what is the first x value where this is increasing?
0.
Yes. And then when does it stop? Yes. I'm very proud of you all for using x values. Ms. Stewart did a good job. So these intervals are always going to be x values. Now one thing you might not have done in Algebra 2 is that little u means union. It just means it's going to be this interval and also this interval. No big deal. All right, you guys do the other interval of increasing for me, please. All right, thank you. So it's this little guy right there. All right. So we already talked about this, that rate of change and slope are interchangeable pretty much. And so we have two graphs here. This one looks like, I have like all the parent functions up on the wall. Well, not all of them, but a lot of them. So you probably recognize the first third, that reciprocal one, or the first 2/3. The reciprocal one you probably didn't do, but logarithmic, exponential, all the polynomial functions, I feel like you got that. These last ones that are the trigonometric functions, you never learned those, but you will, and they're awesome. You're gonna love them. So this kind of looks like exponential decay. I don't know if it is, but that's what it looks like. And so it says that this function f is positive because all the y values are positive. It's all graphed above the x-axis, so that's why it's positive, because it's up here. And then it tells us that f is decreasing because everywhere from left to right we're falling. And then the new thing, the rate of change is increasing because the graph is concave up. So even though this is just half of a cup, it's still concave up, so the rate of change is increasing on this whole graph. That's the big new thing for today. All right, and then this one. Okay, without looking at the words, would you guys say this function is positive or negative? Negative, because everywhere is below the x-axis. Would you say this function is increasing or decreasing? Increasing, because everywhere we're going up from left to right, the y values are getting bigger. Would you say this function is concave up or down? Down. It's half a frown. This is concave down. All right, would you say the rate of change is increasing or decreasing?
Decreasing.
Yes, concave down, rate of change is decreasing. Always, always, always. Okay, let's go. I don't know how we're doing on time. I feel like I'm behind for some reason. All right, so AP Pre-Calculus has been offered 2 years. Both years, I was hired to grade the free response questions. So the multiple choice is graded by a computer, but the free response question is graded by actual people. And so the first year, I graded free response question 2. This summer, I graded free response question 3. And this is like 3. The 3 has 1, 2, 3. This is the third part of 3. And it's exactly like this. And so I like grading because then I know how you guys will be graded, so I'll know what to tell you to make sure you do or make sure you don't do it. I think it really does help. Helps me and helps you guys. So finding these ordered pairs is something that you'll learn to do later. So we're just gonna say we already know these ordered pairs. This graph will always look like this. It will always be called H on number 3. It's actually going to be either a sine or a cosine, so that kind of changes from problem to problem, so you can kind of tell it looks like that on the wall. You'll always have this F, G, J, K, P. So what changes is sometimes the section we're focusing on, it goes from F to G, sometimes it goes from D to J. That just changes from problem to problem. This one is going from F to G, so I'm going to focus on that. So it tells you T1 is F, T2 is G, so we're focusing on that interval from T1 to T2. Now question 1, you can answer before today. You can answer this question in Algebra 2. It has nothing to do with concavity. So it's just asking about the function h. So in this little section right here, from f to g, we want to know which one of these is true. So we want to know if h is positive or negative on that section, and we want to know if h is increasing or decreasing. Now what's throwing some people off today is because on this one, this dotted line is the x-axis. Because those are 0, it changes from problem to problem. And so when you're deciding positive or negatives, what you need to do is look at the y values. Are those y values between here, are they positive or negative? Positive. So it's definitely going to be either A or B. Right? And then we're just looking at this little section right here, not thinking about concavity. This does not use concavity. Would you say the function's increasing or decreasing on that section? Decreasing. And that's it. You could do that last year, 100%. This one you could not have done. So this one is only about concavity. So this question is going to ask you to do two things. First, it's going to ask you to describe the concavity of the graph of h. So I'm just going to start off and say the graph of h. I really like to quote the problem on here, so because it says graph of h, I'm just going to say the graph of h is, alright, so looking at that little section from f to g, would you say the graph of h is concave up or concave down?
Concave
Just
down.
down. If it looks like a frown or half of a frown, it's down. So the graph of h is concave down. And I'm going to go ahead and quote this part too on the interval T1 to T2. If you leave that off, it's okay. It's not a big deal. Right? And then the second part of the question says to determine whether the rate of change is increasing or decreasing. What you chose up here has absolutely nothing to do with what we're about to choose, okay? They could match, they could not match. They're not related at all. So what matters is what you write here. So if you say that in this interval, h is concave down, what does the rate of change have to be doing? Decreasing. That's what I didn't get clear the first time I taught this today. They just got really confused, but these two have to go together on this question. And if it's set up, this would have to be increasing. Again, what we choose here has nothing to do with what we choose here. Alright, let's do another one. So here we go. This obviously is not the x-axis this time because these are going through a -4. So we don't even have the x-axis on this graph. Okay, so this time we are going from K to P. We're talking about this section right there. Alright, so you guys see if you can figure out one on your own. Positive, negative, you're going to look at the y's. And then increasing, decreasing, just normal. Is it rising or falling? What do y'all think? Yes, C. Negative, because those values of y are negative in between there. And increasing because we're rising. Okay. So here we go. Sorry you don't have a ton of room. But we're going to say the graph of h . What do you guys think? Concave up or concave down? Does it look like a frown or does
down.
Yeah, this is down again. I really wish it wasn't, but it is. So this is all down. This is the section that's up. It's okay. It's brand new. And the rate change of h. What do y'all think? It's decreasing. Down is going to be decreasing. Now, people they would say things so weird and they would miss this question. They would try to be super fancy. They'd say the rate of change is decreasing at a decreasing rate or something like that, and that's wrong. So don't get fancy. Just say the graph of h is concave down, the rate of change of h is decreasing. That's all you need to say. You don't get points for being fancy. It kind of a lot of times make people wrong when they try to be fancy. Okay. So day 1, you guys learned how to get 2 points on the AP exam. It's pretty exciting. All right, so we still have a whole bunch of examples, but they go pretty fast. So for the next page, we're going to use this graph of K to answer 4 questions. And so example 5, we want to know on what intervals is K negative and decreasing. So negative, we're going to be below the x-axis. Yes. Decreasing, we're going to be falling. Falling below the x-axis is from D to E, which is choice C. Nice job. Alright, the rest of these are kind of hard for me to do because I have to flip around. So on example 6, 6 and 7 are all about the rate of change. So be careful. Don't answer questions about the function when it's about the rate of change. So we want to know is true about the rate of change. So A says that the rate of change of K is negative. I've moved over that too fast in every class today. Do you know what it's going to look like when the rate of change is negative? It's okay if you don't. What is rate of change the same as? Slope. So it's just going to be like there's a negative slope. So rate of change is negative, will be falling. I left out the word of, sorry. Rate of change is positive, is going to be a positive slope or increase or growing. Alright, and so that's it. So we're looking to see what's true about the rate of change. So you guys look at those choices. The rate of change is positive from D to E. I don't think so. It's okay.
I read that wrong.
It's okay. What do y'all think? It's not a big deal. D. So the rate of change is positive from E to F. So that's this little guy right here. Positive slope is going to be positive. Fine. Alright, and then 7. Which of the following statements is true about the rate of change again? So for increasing and decreasing, what do we need to know? What does it tell us? Concavity. So concavity is what we're looking at here. So for A to be true, then the K needs to be concave down on that section. Is it?
No.
A to B? No. Is K concave up from B to C? No. Is K concave up from D to E? It is. You're right. It's hard for me to see it. Yeah, D to E. All the way to F, D to F is concave up. Alright, so the answer is D. And then 8, on which of the following intervals is K increasing? And the graph is concave down. So increasing and concave down is going to look like this. So what do y'all think? Yep. Good job. Alright, one more page to go. We don't usually have 3-page notes. Well, actually, sometimes we do. When there's a lot of multiple choice questions, they take up a lot of space. Alright, so on example 9, we want to know the intervals of decreasing. Is this that? I think it's the same graph we've done already where we did the intervals of increasing. Alright, what do you guys think?
-1 to 2.
Nice job. So that's good old algebra 2. Decreasing is there. Alright, the intervals negative and increasing. So below the axis.
-5 to
really the only section that's negative, but it also is increasing there. Alright, and then one more, or two more questions. So we have this graph G, it's a curvy graph, and we know that point A is at negative 1, 0, and it's the only place where the concavity changes. So we have concave down changes to concave up at that point. I'll tell you what that point's called later. Alright, so we want to know the intervals at which G is decreasing and the graph of G is concave up. Decreasing and concave up. That is all concave up, but is that all decreasing?
Negative 1 to 1.
Good, you're good. So negative 1 to 1 is concave up and decreasing. Alright, and then last question, on which intervals is the rate of change positive? So we have a positive slope and decreasing. So what kind of concavity are we looking for?
Down.
Yes.
Sorry.
You're fine. Alright, what do y'all think?
What?
Hold on.
Negative
Did I tell you guys something wrong?
Negative 5, negative 3.
Yes. It's okay. So positive is a positive slope. So we're increasing and concave down. So it's another guy that looks like that. Yeah, that's negative 5 to negative 3. It's alright. You're going to get really good at this by the end of the year. I promise you will. Don't stress.